Okay, so now we are moving on to Geometry 4.4, pages 240 through 246. And we are continuing to look at congruent triangles, but this time our congruent triangles are going to be congruent because they have a side and an included angle and a side that are congruent, and they have a hypotenuse and a leg that is congruent on a right triangle. It has to be a right triangle. So this is side, angle, side, and that means that it has to be the included angle of the sides. So it has to, this is an included angle. Oops. Side, included angle, side. Side, included angle, side. Now, just in case you don't remember what the hypotenuse is, the hypotenuse is the longest side, and it is opposite on a right triangle. It is opposite the right angle. Okay, this is the hypotenuse and this is the leg. So if the hypotenuse and the leg are congruent on two triangles, and it's a right triangle, then you are looking at two congruent triangles. The whole triangle is congruent. Let's look at number 3. Number 3 on section 4.4. It has a parallelogram. It has labeled X, Y, Z, W. Okay. Now it says in number 3, it says use the diagram to name the included angle between the given pair of sides. And on number 3 it gives you XY and YW. Alright, so let's find XY, that's here, and YW, that's here. So the included angle is angle XYW. This angle is the included angle for these two sides. Alright, let's look at number 5. We're doing the odd numbers, numbers 3 through 15. We will do the odd numbers. So we look at number 5, ZW and YW. So ZW and YW. The included angle then is here. Angle YWZ. So please use that to help you with number 7. And then we will move on to number 9. If you need to pause here to do number 7, please pause. Number 9, decide whether enough information is given to prove that the triangles are congruent using the SAS congruence postulate. So we have to use side, angle, side postulate. Okay, our figure is another parallelogram, and it's divided into two triangles. We have triangle A. Let's see, they have alright, a parallelogram. Angle B. Whoops, I divided it the wrong way. It's divided like this. Okay, angle ABD is congruent to angle CDB. Alright, so we need to determine if triangle ABD and CDB DB is congruent, or if we have enough information to determine whether it's congruent using the side angle side theorem. So we have, or postulate. So side ABD, AB is congruent to CD. We know that A and D and C and B are congruent because they are marked as such. And we know that the lines are parallel and these angles are congruent. Side, angle, side. Based on the side, angle, side postulate though, well, these are parallel lines, so that makes these parallel, but it doesn't give us, I mean, it makes these congruent, but the figure doesn't show those as congruent, so technically there's not enough information provided unless we dig deeper and base it on postulates and theorems. So we are going to say here that in order to show that these are congruent, we would need to know that sides CD and sides AB are congruent based on the given information. Okay, so the given information does not show side, angle, side. This is the interior, this is the included angle, so we would need these two sides to be congruent. Obviously this side is, but it doesn't show us or give us that this side is. So based on the given information, we can't show that. Let's look at number 11. You can use what we just looked at here to do numbers 11 and 13 and 15. Alright, let's look at number 17. Pause if you need time to finish numbers 11 through 15, and unpause when you're ready to move on to number 17. So on number 17 we have a regular pentagon. Okay, this regular pentagon is labeled RSTUV. And it is marked with a couple of free triangles here. And it asks you to name two triangles that are congruent. Explain your reasoning. Now, a regular, anytime they put the word regular in front of a shape, like a pentagon, you know that all the sides are equal. So we know that every side on the outside is equal. They're congruent. And this will help you determine which two triangles are congruent. Use that information to help you determine which two triangles are congruent. let's move on to number 19. And let's skip 19 through 36. We aren't going to complete any proofs today. So we'll actually move on to the mixed review. Let's look at the mixed review. Page 246. Number 40, we will do every problem of the mixed review. Numbers 42 through 48. So let's look at number 42. Number 42 says a pentagon that is not regular. Draw a figure that fits the description. So not regular means that the sides aren't equal, that all sides aren't equal. And that should be easy to do considering that has 5 sides, but they're not all equal. Alright, 43, a quadrilateral that is equilateral but not equal angular. Okay, so that means you're going to draw a 4-sided quadrilateral that has the same size sides but doesn't have the same size angles. I'll let you attempt that so that we aren't doing every single one together. Let's look at number 44. Write an equation of the line that passes through point P and is perpendicular to the line with the given equation. So you will go back and look at the perpendicular lines for the given equations from our previous chapter. Remember to use, so I remember when we did these before, people would get stuck on how to set up the equation in the first place. Alright, so in order to solve here, you see that 3 and -1 are two points on this line. And then they give you actually the equation of the line that's perpendicular with the given equation. So you see that this is y equals -1 is your slope. Remember, when there's not a number there, it's still a 1. So you have a slope of -1, okay? And you need a line that is perpendicular to -1.